Hello, my friends. Welcome back. In today's video, I want to talk about multithreading in Python, what it is, and how we can take advantage of it to speed up our code, right? We can take advantage of, using more than one thread to do some parallelization and to speed up the calculation that we're running in Python or in any other programming language. But here we're specifically talking about Python. So let's not waste the time and get started. The first thing I want to do is to import the time library. You will see in a second why I'm using this, but basically all you need to, take advantage of the multi-threading features in Python is this. I'm just going to go from threading, import thread, right? So this is all the libraries that we need. As I said, like you don't really need the time library. I just need it because like I want to use it. You will see how in a second. But basically, in theory, this is all you need to take advantage of multi-threading. So now let's define a dummy function. So I'm just gonna go define dummy func1, for example. There is no input to this function, and basically all it does is that I'm just gonna go counter equals 0, and then I'm just gonna go while counter less than, I don't know, 5, for example, then keep incrementing the counter, right? Or you can basically have a for loop, doesn't matter. I just want to show you how, like the concept of multi-threading. So I'm just going to go print, and I can go here, dummy function 1, and then from CMTR, right? And then we go time.sleep. If I don't do this time.sleep, it's just going to be super fast, right? And we're not going to be able to see much. But I'm just going to go like between each iteration, sleep for a second, and then like go back up here and repeat the calculation. So basically, this is like all I want from the dummy function 1. And then the other thing that I want is a second dummy function. It's basically the same thing, right? And I just want to change the name of the function, right? So this is all about the dummy functions that I want to use. And now let's see where the multi-threading comes in. I'm just going to go if underscore underscore name underscore underscore equals equal underscore underscore main underscore underscore, and then I want to say, okay, dummy function 1 and then dummy function 2, right? Nothing too specific about this program. It's just going to run the first one, and then after this is done, it's going to start doing the second one, right? So if I run this, you'll see that it's saying dummy function 1, run 2, run 3, run 4, run 5. And then after that's done, it goes to, like down here, it goes to dummy function 2, right? Nothing, as I said, very specific about this so far. But now I don't want to run it like this, since these two functions are totally separate functions, right? I'm not going to use like the outputs of one of these functions as an input to the other function. So I don't really have to wait for the dummy function 1 to be done so that I can start doing the second function, right? This is the opportunity for us to use the multi-threading to speed up the code. I can run both these functions at the same time, right? Because they're totally independent. How can we do that? It's super easy. So let me just comment this out. And I want to go thread 1, for example. That's equal the thread, the library that we imported, right? And you just give it a target. You say target, that's the name of the function that you want to call. In this case, it's dummy function 1, right? And then you do the same for the second function, right? You go thread 2, and the target for that one would be the second function that we have. And now that we have created the thread objects, we can start the threads. We can say thread 1 dot start, right? It actually starts doing the job, and then we can do the same thing for thread 2. So yeah, we can go start here as well. And then once it's done, we can just basically say thread 1 dot join. This is just like the syntax that you're supposed to follow. Nothing crazy about this. And so thread join, and that's it. But you could actually like add this start up here. We can just cut this and like bring it up here. Doesn't really matter. I did it this way because I wanted to show you the steps exactly. So now if I run this, right, and like before doing that, actually, let me do something else here. If I comment this out and bring this back over, let's say the sleep is like, make it faster, like 0.7 for that one and 0.3, for example, for this one, right? And clear this. Let's run this again. This is not multi-threading yet, right? Because this stuff is commented out. So you'll see function 1 is done completely, and then it goes running function 2, right? Now, if I take this out, let's say I don't really need this anymore, and I want to run that using the multi-threading feature in Python. And if I do this now, you will see that it's like all over the place. It says I'm doing dummy function 1, run 1. Then I'm doing dummy function 2, run 1. And now I'm doing dummy function 2, run 2. And then dummy function 2, run 3. And then I go back to dummy function 1, run 2. So you see that like these functions are being run at the same time. They have different sleep values. This is like the reason that I added the the time library and the sleep method here as well, so that like you can see what is exactly going on. As you see, these two functions, dummy 1 and dummy 2, are being run at the same time independently. That's awesome. That's so cool. So now that you learned this, you probably want to go on your own and start, experiencing things. And then like you want to define your own functions and do some calculation, do some, I don't know, like parallelize some of your computations to speed up your code and stuff like that. But the thing that you are going to notice once you start working with this is that you can actually return a value. So for example, here, let's define a different function. If I go def dummy function 3, for example, and I'm gonna give it, I don't know, list size, and I just want to say let's close this guy, and I just want to say list, like L, sure, for list, it's an empty list, and for I in range of list size, which is an input argument, l.append pi, right? And I want to return, I need to go, what did I do? And I want to return L. Okay, so this is my third dummy function that I have. And now I want to use this, right? Let's comment this out now and just space these so we know that these are different runs. So here I can say, let's say, let's call the functions, right? Let's basically do what we did here. I'm just gonna copy this and be like, okay, I don't know, just give it a thread name, thread 3, for example. That's equal thread, and target would be dummy function 3. In this case, our dummy function is getting an input, right? How can we pass an input arguments? All we need to do is to go args equal and he brackets, we go L size, right? That's the name of the input argument, right? We call it L size, and we have to define L size though. So L size, that's, let's say 5. So it gets L size, and usually just go common space because there might be more. So yeah, that's the thread. So we're passing input arguments, and then we can go thread 3 dot start, basically, just like following what we did there, and then thread 3 dot join. So it's supposed to run the function, right? And this function, as we saw here, is returning a value. Well, in this case, it's a list that it's returning, right? But how can I get the result? Like, how can I get the return value? If I run this, it's gonna run no problem, as you see. Like, it's not erroring out or anything. But if I say print, for example, this guy, it's not gonna like it, right? It says, well, it's not gonna error out, but it says none. There is nothing in there. I don't have any return value. Then how can we do this? Because like the multi-threading feature comes in handy when you are specifically like doing some computations and you want to get the result from one, and like do like bunch of them at the same time. And then once you have the results, then use the result to do something. You probably want to return some values, right? So let's fix that. To do that, we need to make some modifications to the actual threading function, the threading library here. So I'm just going to define my own class. I'm just going to go class, and I'm just going to call it custom thread. And I'm inheriting from this thread class, right? As you see, like I'm saying that the custom thread, we've talked about this before, how we can inherit from, different classes. I'm saying it's like a subclass of the thread class. This way, the custom thread, the thing that we defined, has everything that the thread class has, okay? So all we need to do here is to go define __ init, as always, right? And I'm just gonna give it the self. And you don't need to worry about the, the other arguments, but we can like, to be thorough, we can actually say group equals none. These are just like the default values from the thread library that we were bringing. Just want to initialize them in our class. And then target, that's also none. And I think like you have to define name, that's none too. And then we have args, which is a tuple. And then we have k perks, that equals this guy, and then verbose, that's also none. Hopefully that's it. If it needed anything else, we can always come back and add it. So basically, I'm just gonna go thread dot __ init __ and just call that, right? Self group target name args, and finally this guy. And then here we want to make some modifications. Here we want to go self dot, let's say we call it _return, because it's a local value return, that's equal none for now. And then let's define another method so that when we run it, it's just going to do this. So define run, it gets the self, and basically if self dot target is not none, right? Okay, we spelled it right. If this is not none, then we go self dot _ return, that equals self dot _ target, So these are the values that are coming from the top class thread, right? So target, and I'm just gonna go self dot underscore rx, and then star self dot underscore rx. Okay, and that should be it. And then we can finally go define. Let's define our join as well. So self, and then if we go thread the join self, and then return. This is actually where it's supposed to return the value. Now, hopefully it works. Let's see. Self.return. So now we have our own class. Now that we do, instead of like defining this guy, I'm just gonna copy this line, right, and comment it out. And instead of using the thread, I'm just gonna use our custom thread that we defined here, right? And everything else should be the same. So if I run this now, okay, it's not happy with something. Line 29. Let's see what we've done here. It says if self underscore target. So let's clear that and then run that again. And ta-da, we have a list. And this is what the dummy function was doing, right? We said like the list size is 5. So it goes from 0 to 4. That's the list that it creates for us. And now with this modification that we did here, we were able to return the values, right? Well, you don't have to print it. You can assign it to some variable and then like you use it later if you wanted to, and things like that. I think this is all I wanted to talk about today. I talked about multi-threading, how we can use that to speed up your computation and your calculations, stuff like that. And then the most important thing, in my opinion, is how you can actually return some values, because if you keep using the standard thread, you're not going to be able to do that. And this is just not fun. You would have like print the value here, but which is not really useful. But doing these modifications just makes life super easy, and you should be able to use it now. Well, thank you for watching me, and please don't forget to like and subscribe to my channel, and see you guys in the next video. Take care. Bye bye.